few of these example problems from the probability test, the test 2 material. So these are just the basics, the first 6 problems here that I'm going to do. So this is question 1 this week, and this is just a notation question. So if A denotes some event, what does A with a bar over it, or A complement, denote? So the first part of this is the complement. Alright, so if event A denotes the complement, or sorry, A complement denotes the complement of event A, meaning that A and A complement share some but not all outcomes. No, that's not what A complement means. Alright, this is our answer. Event A complement denotes the complement of event A, meaning that A complement, or sometimes we call this not A, consists of all outcomes in which event A does not occur. So these are basically opposites. Alright, and then if A is 0.9997, what's the probability A doesn't happen? That's what this is asking us. So the easiest way to compute this is to know the rule for complements. If you know what the probability of an event happens, the probability the event doesn't happen is 1 minus that. So there's our answer, 0.003. Alright, now something that's very similar to this, if probability of A is 0.997, is the probability of not A unusual? Yes, and remember, unusual, we're going to use 0.05 to be the cutoff for unusual. So anything below 0.05 is considered unusual. So this is asking, is A complement unusual? And we've computed a probability of 0.003, which is less than 0.05. So it is unusual. Alright, something similar to these problems are 9, which is very similar to 1. On question 9, it says a research center poll showed that 75% of people believe that it's morally wrong to not report all income tax. What's the probability that someone does not have this belief? Right? The probability someone does not have this belief is, again, it's 1 minus that, but you have to change that 75% to a decimal, so 0.75. That means that 0.25 is the answer we're looking for. Now notice they don't want it as a percent, type an integer or a decimal, so make sure that you're reading that part. Alright, and then something that goes with that unusual would be question number 6. A test for marijuana usage was tried on 240 subjects who did not use marijuana. The test result was wrong 53 times. Based on the available results, find the probability of a wrong test result for a person who does not use marijuana. Okay, so that was wrong 53 times out of the 240 subjects. So it was wrong roughly 22.08% of the time. So the probability, they want it to 3 decimal places, 0.221. And then it asks us, is it unusual for the test to be wrong? Again, unusual is our cutoff for unusual is 0.05. So this is much higher than 0.05. So that would not be unusual. 0.05 or lower is unusual. Alright, now, I know I'm kind of jumping all over the place, but I just want you to see problems that are similar. Question number 1 had that complement look to it. Question number 9 was strictly about a complement. And then question number 1 also talked about something being unusual, as did question number 6. So I just want you to see that some of these things, even though they have different looks to them, they're basically asking you the same types of questions, just in different ways. Alright, now these 3, I promise you, I'll go in the just straight order. Alright, back to just basics of probabilities. A probability has to be between 0 and 1, and it cannot be negative. So they want us to click all the values that cannot be probabilities, not the ones that can, the ones that cannot. Alright, 5/3 cannot because it's bigger than 1. 0 can be a probability, it's the smallest possible probability. 3/5 can be a probability. Negative 0.53 can't because it's negative. 1 can be, again, anything bigger than 1 can't be. g is completely valid, but then the square root of 2 is around 1.4 or something, so it can't be. So those are the 4 values that cannot be a probability. Alright, got to be between 0 and 1, so that takes out the negatives, takes out anything bigger than 1. Alright, over here is our data set we're dealing with. A couple's wanting to have 3 children, and these are the different possible combinations they can have. There's 3 kids, 2 combinations for each kid, so that's 2 times 2 times 2. That's why we're getting these 8 combinations. Alright, so the first thing they want, what's the probability of exactly 0 boys out of the 3? Another way to say that, it's all girls. So there's one outcome, this one down here at the bottom, out of the 1, 2, 3, 4, 5, 6, 7, 8 outcomes that are possible. One outcome has no boys, so 1/8. Alright, then the second part they said, what's the probability of exactly 3 boys? Well, that's the same thing as the original. There's just this one. All 3 are boys out of the 8 possible outcomes. So 1 out of 8. Alright, and then the last part. Among 3 children, exactly 2 are girls. So you got to be careful here, because if you're just looking and there's the first time I see 2 girls, and if I just write down the 1 out of 8, you got to be careful, because this is the way that we can have 2 girls if they're the youngest of the 3 kids. And then I could have 2 girls that are the oldest of the 3 kids, but I could also have a girl and then a boy and then a girl. So there's 1, 2, 3 ways to have exactly 2 girls. So that's 3 out of 8. Alright, so be careful when they're asking you for anything more than all 3, 100% are boys, or 0% are boys. If it's any other number, 1 out of 3, 2 out of 3, you got to make sure that you're careful and find the ones that of the 8 outcomes that satisfy that. Alright, 5, we got a sample of 100 colored candies. There are 22 red, 53 blue, and 25 yellow, and none of them are brown. So I wonder why they even put that in there. Estimate the probability that when a candy is randomly selected, we get one that's blue. Alright, this is exactly like this question back here, except there was one way to get all girls, one way to get all boys. This question is basically doing the same thing, except it's how many ways are there to get blue candy? There's 53 ways, because there's 53 blue candies in there. Right, so there's 53 out of 100, but they want a decimal or a fraction, doesn't matter. So I could put 53 hundredths. I could put that in there as my answer, or I could put in 0.53. It's just up to you, because they want either one. Alright, does the estimate roughly agree with the claim? The maker of the candy claims that 24% of its candies are blue. Does the estimate from part A, 0.53 or 53%, agree with this claim? No. It's more than double what the claim is. So if this had been something like, 0.26 or 0.23, then yeah. But if it's, getting up above 0.3, then we're starting to get to where there's a substantial difference, especially when we're more than double. Alright, fill in the blank. The blank for procedure calls this just just understanding terminologies and probability. The blank for procedure consists of all the possible simple events, or all the possible outcomes. It cannot be broken down any further. So in class, you'll hear me say, find all the possible outcomes, or sometimes I'll say this phrase, find the sample space. The sample space is all your possible outcomes. Alright, so that's the first part of this probability. We'll have a few more that I'm going to make videos of, but these first 10 questions basically are just the terminologies and the very basics of probability.